Hello and welcome to this new video. So today I'll bring you some updates on fastmeshapi, which is a Meshtastic-related web app. You can see the previous videos to know what I'm talking about, but the new update doesn't involve the node list, which remains the same. Now we have some new data in the packets table. Okay, so let's connect to the radio first. Then let's go back to the table here. Okay, so now the first 5 columns are the same, so we still have the ID in the database for each packet, the packet type, the packet source radio, the packet destination radio, the reception time. Now we have the data column. The data column contains for each row a subtable. For example, here this is a position subtable. Okay, and it contains the packet information, where you have latitude, longitude, altitude, location, source. And then there is also the telemetry subtable. Telemetry has different cases. And this is a specific type of telemetry, the device information telemetry. And then we also have the node information subtable, which I decided just to put the node role and public key, but there are also other fields, possible fields. And there is also the text messages packet with its table where it has just the text message. So these are already readable. The next important thing is that the table now auto refreshes. Yeah, at the moment it's not very efficient, but it kind of works. So here when a new packet comes in, the first element of the table corresponds to the newest packet. The oldest packet gets pushed out of the table. So eventually packet number 949 will get removed from this table. And this is implemented using a WebSocket, which we'll see in a moment. The problem now is that the information in the column data is always pulled for each row, but this is not the intended behavior. The intended behavior is just to update the first row. We don't need the information of all these other tables because it will remain the same. At the moment it's very inefficient, but eventually it will get fixed. See? Here we have 100 calls just for each packet, and in the end it will be just one call. So now I'll just quickly show you how the database models are implemented. So now we have a common packet table with all the common fields for each packet. So packet ID, from, to, etc., etc. And this packet table connects to other subtables. To one of these other subtables. For example, if we have a telemetry packet, it will only connect to a telemetry. This is the telemetry packet table. Then there is also node info position text, and we can distinguish between packet types using this field, which is a string. Packet type choice is here, is an enumeration, but yeah, in essence it's a choice of strings. So node info position telemetry text. And we also have its packet ID. So for example, if you have a telemetry type packet, it will go here to the telemetry instance. And if you see here, we have the connection to the packet table. Same thing is true for the node info here, the position here, and the text for the text messages. So it will be one of those 4 cases. So once a packet comes in, it will trigger an event. This onReceive function will be triggered. A new packet instance will be created with all the fields here. And then for each packet, for example, for the text packet, we have these 2 tables, text decoded and text. Okay, see, this is the reference to the common packet table. Similar type of implementation is done for all the other packets. So position has its subtables, still the connection to the packet, and when we have the node info, same thing here. Telemetry is the one most complex because we have different types of telemetries, so we have to keep that in mind when we are showing them in the front end. Once you write the packet to the database and also the packet type, so we add the packet to the database session, we commit to the database. Then we have to create some information for the WebSocket. So the WebSocket is a system, said in just a few words, is a system to exchange simple messages in a light way, in this case between the browser and the server. And the connection remains always open, so the messages come real time as events. And the kinds of messages we need are JSON objects, because we can structure the data in a better way. And for example, here we have, we need to know which object is being updated in the database, so the front end will keep up with that update. Object attributes, we have the packet type, as I said, telemetry, text, position, node info. This will be the text here. Then we have the packet ID. Okay, so this is the message that comes in. So let's see one of those messages where I printed. Okay, object type, object table packet, packet type telemetry, ID 1069, which is this one here. Oh, see, new packets are coming in. This one here. So what the front end is doing is reading this information, going to the API. We know it's a telemetry type of packet, so it's going to this new endpoint here. This endpoint, if you write the packet ID, execute. Okay, we have our data, telemetry data here. Here we have a nested structure because of the type of different types of telemetries. In the other cases, it will be a flatter data, but works in the same way. And in our front end, this is the main view, right? The main dashboard view. Now we have the WebSocket. So the endpoint is /ws. And each time a message comes from the server, this routine is triggered. We have the event, which will be the object, and then it will have the data attribute. It will be parsed as JSON. Here I printed just for debug. And then the new packet data is fetched from the backend using this new function here. V0 packets combined base ID. It's doing that. C780, let's see, this one is our prettified data, because for example the from ID is being changed from the default ID. This is the short name. It's going there. We are reading our data. We are updating the Svelte store, updated data. And so this new data structure, this new list is being created. The last element is being popped or removed. We also updated the icons. The icons you see here, these ones, okay. These ones are being updated. And this is going to be reflected in the second table here. Table rows packet data. And then the new column is this one here, column header data, and I separated to a new component because it was getting complex. Okay, so this is the packet card component. In the front end, we are creating a card, a Bootstrap card. So each card can be of one of the 4 types of supported packets at the moment. You see here, packet type telemetry, text, position, and node info. Telemetry has its subtype, device metrics, environment metrics. Okay. At the moment you can see the problem here, because now it's every time a new packet comes in, there are like 100 requests just for a single packet, because it's updating all the tables in the data column. A fetch for all these elements here, which is not efficient, because we just need the last, for example here we just need this table here, not the rest, because the rest of the data will remain the same. This is the aim at the end, so this should be fixed by next time. And also the position data, instead of having textual data like this, it will be nice to have a small leaflet map which fits inside a row. I think that should be much better with a pin, you know, the blue pin leaflet thing. I mean, like this one, yeah. Okay, so I think we can finish the video here. If you like the video, put a thumbs up and subscribe. And as always, bye bye.